Hello everyone. Welcome to the Mathematics 10 2.1.4 Modeling Using Systems of Equations. Before we get started, there are some prior knowledge that you need to know. You need to understand and write an algebraic expression for 5 more than twice a number, or to be able to solve systems of equations such as x plus y equals 20 and x equals 5, and you find the other variable. The objective is that you can translate real-world word problems into systems of linear equations and solve them to find the unknown quantities. Let's try the example question here. Nicole works at a farm. She needs to plant a total of 32 bulbs. The 2 types of bulbs are available, and she is asked to plant 3 times as many crocus bulbs as tulip bulbs. How many of each should she plant? So let's try this problem. And the first thing that I'm going to do is to write down the unknown values and declare them. And when I declare them, I'm going to make sure that I use the let x be statements. I'm going to say that let x be, well, the unknown values in this case is the number of crocus bulbs and the number of tulip bulbs. So I'm going to say let x be the number of crocus bulbs. And let's do the similar thing for the number of tulip bulbs. I'm going to say let y be the number of tulip bulbs. It's very important that I declare them explicitly so I know and I can remind myself of what I'm looking for, and I can communicate with the reader of my work solution. After you declare the variables, let's read the sentence and try to translate. She needs to plant a total of 32 bulbs. So that means that total number of bulbs is 32. For me, that sounds like x plus y equals 32. And the third sentence says, she's asked to plant 3 times as many crocus bulbs as tulip bulbs. So that means I have more crocus bulbs than tulip bulbs, and exactly I need 3 more times. So for me, that sounds like that crocus bulbs, x, can be represented as 3 times the tulip bulbs. So that's x equals 3y. 3 times as many crocus bulbs as tulip bulbs. So that's x crocus bulbs is 3 times y. So I translated the sentences, English sentence, into a mathematical expression. Now, let's solve them. Well, this is a perfect example of a linear equation, systems of linear equations, and I think I can solve this easily using the substitution. I'm going to substitute the x in the first equation by 3y. Make sure you put a bracket around the first step. In this case, there's no need of bracket. 3y plus y is 4y, which means x, not x. So that means y is equal to 8. And I think we can easily deduce that x is going to be a total of 24. Then I can write my final answer that y is 8 is x equals 24. You don't want to leave your answer like this. When you solve a word problem, you should answer in words. So that means I have 8 crocus bulbs and 24. My bad, that's the other way around. See, that's why I declare the variables, so I can avoid that kind of mistakes. Y is the tulip bulb, so I'd say 8 tulip bulbs and 32 crocus bulbs are planted. Will be planted, or something like that. Now let's annotate my solution. The first step is to declare the variables as let x be statement. And this is especially important for the systems of linear equations because we're not dealing with one variable, but we're dealing with two variables. If you don't declare them properly, you will mix the numbers up. And then the second step is to set up equations. And to set up the equations, you need to carefully read the sentences. In this case, I read the second sentence, and that leads me to the equation number 1. And the fourth sentence leads me to the equation number 2. Afterwards, I use a substitution to solve for y, and I solve for x. And then afterwards, I answer the problem. We're having a total of 4 steps. Actually, a 5th step. The first step that was not written here is that we should identify the variable. And we usually identify the variable by looking at the last sentence. How many of each should she plant? So that means the question is looking for the number of bulbs for each case. Therefore, we declare the variables, and we set up the solution, set up the equations, and we solve for an equation, and we answer the problem. Let's try the second example question. The girls' soccer team held a fundraising car wash. They charged $5 for each car and $8 for each van. They washed 44 cars and vans and collected $262. How many of each type of vehicle did they wash? Well, the same thing I'm going to start with is to identify the variable and declare them. Well, we look at the last sentence. How many of each type of vehicle did they wash? So the question is asking for how many cars did I wash? How many vans did I wash? So I'm going to say let x be the number of cars, and let y be the number of vans. And then now let's set up the equations. Apparently I have, they washed 44 cars and vans in total. For me, once again, that sounds like the sum of x and y is equal to 44. And they collected a total of $262. Well, let's think about it. They charged $5 for each car. So that means that for each car, I multiply by 5 to calculate the revenue. So that means I'm going to have 5x. And then $8 for each van. So that means 8y, because y represents the number of vans. So I multiply by 8 to calculate the revenue from that. And the total collected amount is $262. For this one, we could, I think it's going to be easier if I use the elimination method. To do the elimination method, we need to multiply one of the equations by a certain number so that the variables are matching. In this case, I'm going to multiply the first equation by 5. So that means I multiply the first equation, so x by 5, y by 5, and 44 by 5, which is 220. Let's rewrite the second equation. And now, because the coefficients of x are matching, we can eliminate by subtracting the two equations together. 5x minus 5x is 0. 5y minus 8y is negative 3y. 220 minus 262 is negative 42, which means y is 14. which also easily tells me that x is 30, because x plus 14 is 44, therefore x must be 30. And of course, we can easily check by plugging in the values back into the other equation as well. 5 times 30 is 150, 8 times 14, that's 112. So 150 plus 112, 262. And my final answer should be in words. So a total of x is 30, so that's total of 30 cars and 14 vans are washed. Time to do the annotation. First up is always the same. We declare the variable. Once again, we're using the statement let x be and let y be statements. And then I set up the equation. In this case, I got the first equation by looking at that part of the sentence. They washed 44 cars. X plus y equals 40. X plus y equals 44. And then I set up the second equation by knowing that they charge $5 for a car, $8 for a van, and the total collected amount is $262. Afterwards, I solve the equation by using the elimination. So I multiply the first equation by 5 to match coefficient of x. Afterwards, I subtract to eliminate. And I solve for y, and then solve for x. And answer the problem. So let's reflect on the vocabulary and the formula we need to know for this lesson. First of all, we need to declare the variable. We choose the letters and variables to represent the specific unknown quantities you're trying to find in a problem. So that's why I repeatedly say, use let x be, use let y be statements. And then at the end, you need to choose a method to solve systems of equations. Systems of equations has two methods of solving, and one is called substitution and the other is called elimination. In the two previous videos, I taught you both methods, and one thing I can say is that both methods are equally great. The question is, which one is more efficient? Well, the efficiency also depends on the case. Sometimes substitution is more efficient. Sometimes elimination is more efficient. In my opinion, for the two example questions that we did today, the first example question, substitution is more efficient, and the second one, elimination is more efficient. So the practice is in determining which one is more efficient in which case. And as I said earlier, it's only about efficiency. It's not about better or worse. So if you're confident with one method, there's no problem if you only stick with that method too. Thank you for tuning in this video, and I'll see you in the next one.